Okay, let's talk about ionic compounds and how to name them. This is our objective and essential question. I encourage you all to pause the video and write these down. So our objective today will be to describe an ionic compound and name various ionic compounds using chemical nomenclature. And our essential question that you all should try to answer at the end of your notes in your summary today is, how do we use chemical nomenclature to name ionic compounds? So nomenclature is a set of rules, essentially, that chemists follow to determine the name of the compound. So it is a strict set of guidelines with specific steps that we are going to learn today on how to apply these to ionic compounds. So let's review what an ionic compound is. An ionic compound is a metal bonded to a non-metal via an ionic bond. So if we were to look at our periodic table, typically our metals are going to be on one side of the periodic table and our non-metals are going to be on the other. So if we've got our periodic table here, we have our metalloids, which are kind of separating our metals from our non-metals. So our metalloids are going to be around this region and our metals are over here, and our non-metals are typically on this side, with the exception being hydrogen over here is a non-metal. Ionic bonds, remember, are when an electron is donated. So for an example of an ionic bond between sodium and fluorine, sodium is going to donate its electron over to fluorine. And so sodium now is a cation and fluorine now becomes an anion, because fluorine now all of a sudden has one extra electron around it. So it becomes a negatively charged anion. So these are the steps that we're going to follow to name ionic compounds. So the first step that we will follow is naming the first element in the compound. So we're going to use this as an example to our right. Now the first element in the compound, if you were to look on the periodic table for that element, you would see that element is called sodium. So I'm going to write sodium right here. And that is our first step. The second step is to name the second element in the compound, changing the ending to "ide." So our second element in the compound, if you look on the periodic table, is oxygen. And write oxygen here. However, the second step says to change that last ending of oxygen to "ide." So instead of oxygen, I'm going to cross out that last ending, and oxygen becomes oxide. So together, this name is actually sodium oxide. Now that is a simple way of naming ionic compounds when you have a metal and a non-metal. So let's talk about what happens when we have a metal that is in the transition metal part of the periodic table. So remember our periodic table structure. I'm going to give a brief little outline of our periodic table. Our transition metals are going to be in this category. So here are all our transition metals. They lie in between these metals over here, the alkali metals and the alkaline earth metals, and the non-metals and the metalloids. So when we find that we have a transition metal, the first step is to actually determine the charge of the second element. So our second element in this compound is chlorine. Now, chlorine is 1 electron away from achieving its octet. If you look at its location on the periodic table. So it is very, very electronegative. It really wants that 1 extra electron. So it likes to form ions that have a -1 charge. So we have 2 chlorine atoms with a -1 charge. So that is going to give us a total charge of -2 over here. The second step says to name the first element in the compound. So I'm going to just go ahead and name that first element. And then I'm going to add Roman numerals in parentheses that equal the charge of the second element. So we've already determined our charge of the second element, which is -2. So I'm going to use Roman numerals to indicate that I need copper to balance out that -2 charge. And then finally, our last step in this ionic compound is to name the second element in the compound, changing the ending to "ide." So this is the same as our previous problem, only this time instead of chlorine from the periodic table, it becomes chloride. So we're going to drop that ending and replace it with "ide." So our final answer for this question is copper to chloride. Let's do one more example, this time with a polyatomic ion. So as a reminder, a polyatomic ion is when there are 2 or more atoms coming together to form a charged species. So poly, if you are familiar from geometry, if you had a polygon, it means there were many sides. So poly means many. Atomic is simply referring to atoms. So a polyatomic ion is composed of many atoms. So in this case, we have this polyatomic ion. The best way, I wish I had another method for telling you all how to know the names of polyatomic ions, but it is simply to just memorize them. So this is hydroxide, and we will come back to that in just a moment. But our first step is going to be to name the metal in the compound. So here's our metal in the compound. And if you look on the periodic table, again, this is sodium. And our second step is to name the polyatomic ion. So again, OH is an ion that has a -1 charge, and we call that hydroxide. So our name for the compound is sodium hydroxide. So notice the difference when we actually have a polyatomic ion that we don't change that ending to "ide." So all that is left is we are naming it as sodium hydroxide, just the name of the metal and then the name of the polyatomic ion. So I hope this helps, and I look forward to discussing this with you all in class.